This video is about KherveFitting version 1.4 and is targeting to users who have used the software before and want to know the little tips and tricks of the software. So I will start by looking at the survey. So this is a sample which is a hard carbon having a lot of sp2, and so here we have a survey, and the survey shows a carbon 1s, oxygen 1s. And if I just use the control down, I can see that actually there is a peak at 1070, which is sodium 1s. And then we have here the CKLL, which I will explain later. So if you want to use KherveFitting to label your survey, you will use the ID shown here. You can then just use the carbon, oxygen, and maybe the sodium, and then you will use the add label. So, and you can then select the ones you want to be labeled, and we may not want sodium 2p and sodium 2s because it's not too many, but maybe just the sodium 1s. And then when we add the label, we have them shown here. And now let's say this is the sample in the folder. And if I just open the Excel file, you see the carbon 1s has been fitted before, but the survey has not been created yet. And if you just put down, because that may not be the right size, so if you just put down slightly and save the data, then you should have on your Excel in the survey section, you should have now a plot of the survey at the right size. So the size is done in the preference, which you can find on this setting here or in edit preference. And then if you go to save settings, you would have the width and the height that you can change. I tend to put it to put the width twice the height. And for now, I found the DPI level to be 100 to be satisfactory. So this is for you to change. Okay. And you may find that sometimes you get, like we just saw right now, if I open the preference, you may find that the labels is gone. But if you just flip between pages, then it's back. If you want to change the position of the label, you can open this label manager, and there will be a window that pop up, and you can then choose to move it. So for example, if I decide to move carbon 1s, I'll select it, and you can just move it where you like. Maybe that's where you prefer doing it, and you may want to edit it, change the label as you like, or even add some more. Okay, so don't know if this would work. Let me see if this, yep. So that has been changed now, put back using the undo. And let's say now you may want to go further into the survey, and you may want to analyze the picks you have using the survey instead of using the core levels. And for that, instead of using this pick fitting window, you can also use this calculate area on the curve window. That's a yellow background, and you can then, we're going to right click to zoom in. You can then, you should be able to select, I think both have been done, select, let's say this curve, but, and then create a background. Yeah, and you will just get whatever kind of background. You may not be happy with this one. So let's just clear all. you may actually just create this background here, and then you may want to also add a bit more, maybe up to there, create the background, and continue like that. You may zoom out and continue by zooming on the oxygen 1s, for example. And it's often, the second line is often hidden in the right, in the other line. So you just have to move it. Then we can create the background. Now you can see that we have created two backgrounds. On that way you can calculate the area under. But if you wish to use the Tuga, which I would actually suggest to use, we can simply clear all the backgrounds and then use the 1 times U for Tuga, and this button just is now enabled, and we can select using the Tuga. We can select the regions we want to fit the Tuga. And we would like it to use a flat background, so something like this between maybe 520 and 900. So let's just add that in there, maybe 540 and 900. Okay, so that may have been slightly not enough. So let's go from here. And now I can simply use the fit to get the BCD value of the Tuga. And the BCD values will enter them into this window here. So let's do that now. Takes a bit of time because the survey is quite big. And now we get a Tuga which has correct value. Some people may want to have the C slightly lower. The default value by Tuga is to have it at 1643. And in here we have 1100. Okay, so that will give something like this. You can actually change all this by deciding actually I should have something around no, not bigger than 600, let's say. And now if I fit it, then it will restrict the C to be 600, or he found 321. So that may be the one you prefer. And then I'm not suggesting this is the correct one. This is one possibility, and it's for you to find out which one is best. So for the BCD values, now to copy them here, you have a button, copy to pick fitting screen, and this is automatically implemented here. And now if we create the background, we get this type of thing. And you may not be pleased with this. And that's quite correct because it's not fitting quite well here. So I can go back. I can tell him actually you should not be above, let's say 500. Let's redo it. And let's copy it. Let's create the background and see what we got. And again, we did not get a quite good spectrum around there. So let's just zoom into this. Yeah, so we want we want to redo it. Maybe that should be something slightly bigger. As you can see, there is quite a lot of process with Tuga. I think now we are getting to something we like. So we don't want the Tuga to go too far into the high binding energy. We want it to stop and to go slightly higher here. So let's copy this. Let's create the background. And now I think we get something that we are quite happy. So when you want to measure, to quantify the carbon 1s, you should always include the different plasmon, the different satellites. So let's zoom out. This is what we get for now. The label is gone for now, but it should come back once we flip the page. So let's measure the carbon 1s. For this, we have this area calculation. If we zoom in again, and we are going to measure carbon 1s, so we will write carbon 1s, and now we will measure between here and around there. Around there. And we do calculate area. And now we have the area which is provided here as carbon 1s. If we zoom out again, we can do the same to oxygen 1s. Zoom in. You see a nice tuger. And now if I create a new pic called oxygen 1s, and maybe this time, no, it's still not working. Oxygen 1s, calculate the area, and now that's a slightly different color. We get it here. And we can do the same with sodium 1s. And this is, I mean, this is within the noise, but if you let's say, try to do something better. In this case, I'm just going to do that. Let's see if it's still here. Yes. So sodium 1s, calculate the area, and now we only get this little piece. Okay. So if I zoom out, I should get this kind of data now with carbon 1s, oxygen 1s, sodium 1s, and we don't yet get the atomic concentration. We just have to make sure that the RSF library is correct, so we can go into the edit preference and go to instrument settings. I've used the thermo machine, so I have to use the AL thermo 1, but in here you can use the one you would have for your machine. So if it's a Kratos, you'll use the Kratos C1S. If it's a Shimatsu, or a standard library from K-alpha, which is this from CASA, which is the CAL1486. CASA also has the K-alpha library, but I prefer to use the Avantage one, the one provided by Avantage. And then you can also check the library, yeah? Check the values that you would get. Okay, so I haven't changed anything, so I'll just say cancel. And now here we have a concentration, but this concentration is only from the area. So it's expecting to have all the same RSF, which is 1 in this case. That's what it's expecting. But if you now export it to the results grid, then this will provide a transmission function for thermo, which is 1. And the Excel file shows that there is no transmission function, which is correct. And then use the TPP2M ECF correction factor, and the RSF is AL thermo 1, so it's all correct, and this is the corrected area. And now if I click on this value, on this ticks, I get the correct concentration. Okay, so that will be quite different to the core level one, because in the core level we don't really include those loss peaks. Now, there's another thing you can do with this. For example, especially if you have sp2 carbon. So I can show you the sp2 carbon which I had previously fitted. So this is the one, but I have, to be able to get this, I had to look at the D parameter. And so I measure the CKLL, which is shown here. But let's say you do not have the CKLL, you have forgotten the CKLL. For that, you will have to try to crop the CKLL from the survey. So I will use this crop window, which is here, and I will tell him from where to where I want to measure, I want to take the data. So let's say I want to get it from 1180 and then 1000, and this is written here. You see the value here. So 1000, maybe 1256 or 55, 1255. And this will be called the survey XPS crop. So let's do that. And now I am getting something like this. Okay. You may want to change the name. Maybe we'll rename it to something called something close to CKLL. Let me just show you. We already have the CKLL, so I'll call it something else. I'll call it C, let's say OG. Okay, so now this is the COG. And I'll just remove everything I have in there. It looks like we have kept some data. So let's just come out again, because I used the pick fitting remove type backgrounds to remove it. But here I have also a window called the D parameter. So I can measure the D parameter. I could, if I really wanted to, measure the D parameter by first smoothing the data and then applying a derivation. So that will give me the maximum curve here and the minimum plot here. Yeah, very much like, and I'll try maybe using the CKL shown here. So this is a good resolution one done. And I could do this, but I have this D parameter, and this is done straight away, where by default, we have a smooth width of 7 and a differentiation width of 1 and a pre-smooth path of 2. So if I calculate, then the calculation gives me 22.6 for the width of this CKLL. And you can see it's between here and there. So that's my max and that's my min. And I can do the same now using the data I got from the survey, and that's usually not as good as the well-resolved one. But let's try. So if I do the same, and I get 21.5. Okay, so in case you've missed to measure the D parameter, you can crop it from the survey. Now, I will slightly talk about the different constraints. So let me go into another file. Let's say I'll use the LASTO. So this was done before, and I will just redo the whole pick fitting to simply show you. So it's clear all. Maybe actually I will use this titanium one. That's it, because that's slightly more difficult. Okay, so we will use again the multi-region smart, and we will just select this one. We have a nice Shirley background. And then we can zoom in with the control down. You may be happy with what you have. You may want to redo it, and you can redo it again by even just moving that slightly and just recalculate it. Yeah. But if you want to if you want to change the offset, you can see what I just did here. I use the Shift key. And using the Shift key, I can just move my Shirley to wherever I feel with an offset. And that is changing the value just here. So I can then create different region that way, because this is called the multi-region smart. And I'm going to make something which is not correct, but if it's up to you to create your background as you wish. The software allows it. That doesn't mean what I'm going to create is correct. So if you want to move, create a new Shirley from here to there, I'll just move it, create a Shirley here. Okay, so now I decide that the Shirley will start here, and I can move this one maybe from up to there. And now I will try to offset this, and he decided that this is a linear. So it could be a linear. You may just redo it because you see the background is slightly lower. So unfortunately, that's going to be a linear. Okay, but this is one possibility with the multi-region smart is you can create your Shirley, your background as you feel. And all this offset was done using the Shift key. Okay, let's clear all if you like. Let's go back to what we would like to use. And that's just my standard Shirley. And let's zoom out. So I can use the zoom out here. I'll use the right click zoom out. And now let's create a pic. So we can use any models available. I prefer the void. So the void I prefer is this one. This is, as I explained in the introduction, this is the new void function, which is asymmetric. And it's under development. So it works well, but I'm still yet to test it. So let's create a doublet. The first one it will do is this one. We have another pic here. So let's create another doublet. And I will use again the tab button to shift the pic as I like. So I'll take the pic C, and you can see the pic C being highlighted here. So if I use the tab, you can see that goes down. If I use the Q, which is next to tab, that goes up. So you can select it like this. But you can also select by clicking on 5. Now that's selected, and I can drag it. Yeah. You can also use the Alt key. The Alt key allows you to do it manually. So if I do Alt up, because maybe you have to click on the Alt like this, Alt up. So now you can see it going up. You can see it going down simply by using the Alt left or up or down key. I prefer simply to use the mouse, but let's say if I have a trackpad, that's maybe the best one. So now for titanium 2P, it's slightly different because this pic will have a different width. The 3/2 will have, the 1/2 will have a different width than the 3/2. And the software knew that, so it did not make the width of the Gaussian in function of the first pic. But as you can see here, but pic C should be in function of A, because this width should be the same as that. So let me do that. So if I type A, then it will know that A needs to be A times 1. And I can do the same for pic D. That should be in function of B. So B, and then that becomes in function of this pic here. And then the Lorentzian to Gaussian should be the same for all. So in here, if I simply type A, sorry, then now we have pic B, which is in function of A, pic C also in function of A, and pic D, which is in function of C, which is then in function of A. So all of them are the same. If I fit that, now we have a nice fit. and it's done within a couple of iterations. So we don't need the 20 iteration. But let's say now I'm happy with the fit, and I get a split between the model A and B, and the model C and D of minus 2.14. So if I type A in here, and that maybe there is a slight mistake. Let me see. If I type A, then I get this minus 2.4. So the software I'm yet to change that. If there's a negative value, unfortunately, you may have to remove the plus. But now this whole thing, both doublets are linked together. And you can do the same for the area. So let's say the area will also be in function of A, and the ratio between A and C is given here, 7.4. So if I type A, it will know, and it will take these values here. You can do the same for C if you like, and make it in function of B. So if I type B, it will make it in function of B now. But let's make it in function of C, because that's usually the way for a doublet. So something like this. And as you can see, he actually went to 0.55. So now all the peaks are linked together. So and especially to A. So if I drag A, they're all linked. Okay. And if I go down, they're also linked. They all go down. And then I can fit it back. And this is simply done very quickly. So if I do the same to Strontium 3D, I can again create a background very quickly, create a doublet, and maybe create another doublet because I know there should be another one, and maybe put it straight in function of A. That's usually the rule of thumb for the pick C. The width of Gaussian DLG. When I fit it, when I get something like this, if I'm not happy, I will just check what I get, and I'm saying, no, actually, I would like it to be slightly smaller and slightly shifted. I would like it to be here. All I have to do is for the pick CD model to make this one in function of A. And I simply type A, and it will take the split and of 1.23. And now I can refit it, and that's it. It's close to 1.23 because plus minus 0.1. Okay, I could decide to remove that, the plus minus 0.1, and I'll get now maybe a value which is closer to what I would like. And I can decide to simply use hashtag 0.1, and now it will move the value plus minus 0.1 of that one, of that value shown here. Okay, so those are the different constraints that we can use. Let's go now into the binding energy correction. And maybe let's use again the hard carbon that we've used. So we did something here. As you can see, it's all saved. And we can just go to this one. So it has been already corrected. So let me just put that to 0. So if it's been corrected and you're not sure what you're getting, just simply type 0 and then click on the plot. And now everything goes back to the correct value. And if I use the binding energy correction here, it will look for the C, carbon 1s C single bond C. That's what it's doing. And and those values can be changed. But let me show you. So if I do it here, you can see this is being changed everywhere in the program. Everything has been shifted to get C minus C. But if you don't want to use this one, so let's go back to 0 again. Let's go back to 0. And if you don't want to use this one, you can go to Edit Preference and then use a different reference pick. For example, the C double bond C. We want it at 284.5. And you say save. And now, and you could do that in every part of the file. So I could do this change in the sodium 1s if I wanted to, but let's just do it here to show you what happened. So now we get this one, all those peaks reference to the C double bond C, which has been put at 284.5, and that's why here we still get 284.8. Okay, but now let me go back to 0 to show again. So let's say I was on the, let's say, the oxygen, and I was to fit this. Create background, add a peak. There should be more than a peak. Sorry. Okay, add a peak. That's it. And then now I could again use the binding energy correction. And you can see it still look for the carbon 1s C double bond C, and you find minus 0.25. So that was here. Okay. Now, there's other functions, which is, for example, the library. And this was all done using the library. So let me remove the whole lot. And I found something, as you remember, I found something in the D parameter to be 22.5. If I just redo it quickly, 22.6 actually. So this is very, very SP2. And I can use this library. Let me go to this KherveFitting library, pick library. And in here, I have this carbon 1s C double bond C. And actually, this is the datas are taken from a paper from Bissinger. Let me just put that down so you can see. So we have the OC double bond O, which is A plus 4.5 plus minus 0.5. So this is what I'm able to give in contrast to Gaza. And the pi pi or the C double bond C is in function of the pi pi star, or inversely, using the A times 0.072. So I first have to create a background. Okay, so that's done like this, but I found, before I start fitting, I found that I had 22.6 in my parameters. That means extremely sp2. So I can already make C minus C, or single bond C, in function of C double bond C. And that will be something like A times 0.1, so maybe less than 10%, or even less than 5% sp3. So I put that, and let's see if it fits. And I can maybe put that hashtag 0.03, let's say. Okay, so when I fit this, it's already done. Let me see what happened. Yeah, it looks quite good, except my background wasn't done properly, so I can redo it again by simply going from here. And I tend to not include the second PyPy star because from what I've realized is most papers, or at least the Bissinger paper, does not seem to include it. So the area shown here, which is from the paper, would have to be way larger. So the A times 0.072 I've used will have to be way larger if I include the next PyPy star. So now it's all done. I can go again with the fit, and you can see it's all happening and working quite nicely. And for now, it's finding something around 7%, so 0.07. So it wants to go lower. I'm going to give it a slight push. I will allow him to go to even 0.06. Let's see what happened. And you can see now it's going further down, and that's what we see. And I think this is now coming to the best it can. Okay, so this is by using the pick library. You could do the same. There are other type of libraries. So if I go back to my Strontium 3D and use, let's say, the carbon 1s, I will zoom to the carbon 1s and use something, it's quite noisy, but I will use that to pick fit. Maybe slightly more. It's not going to be too good. Yes, we can see that it's not perfect. Let me redo it again. Okay, so it's definitely bad. Something like that. And now we could create a pick library using 3 picks. I think we cannot include more than that because the OC110 will not be there. So I use this one, C3 picks. And you can just fit n times and see what happens. And this gives us the CC we want. We could binding energy correct to that, and you can see the previous one is here. So let's remove that. And you would have to change, because this is CC, so you would have to change that to be CC, maybe refit again, and you could binding energy correct everything using that. Okay, so the last bit I would like to mention is what type of files we get. So I showed you we get this Excel file, sorry, not this one, this Excel file. So this is the one we've just been fitting. We get all those data plus the pick fitting table. And if you want to look further, you can see that there is also a JSON file. And the JSON file, it's an ASCII file, but with plenty of numbers, so it's best to open it with something that can handle JSON type file with arrays. So here I have the Visual Studio program. It could be PyCharm, but there are many different types. So what I can do with this one is I can go down and remove the array by just going like this. And I can simply go down, and this is the structure of the parameter file. So you can see, for example, we had a survey and we did a background. So for now, we are just on the survey. But if I go down, oxygen 1s, sodium 1s, and then carbon 1s, we want to look at carbon 1s. We may want to see the raw data or the background that was used, so it's saved here. But all the PICS parameters are shown here. And you can feel free to change that. If you feel that there is a mistake, an error, you can change those values as you like. Okay. That is it. So other things, other functions that you may want to see is this plot modification, where you can apply some smoothing, differentiation, integration, and constant operation. In here, you can add this. I think it's been added somewhere. I can't see it now, but you can add it a label if you like. You can toggle the data. So maybe that's something quite nice to talk about. So if I go to strontium, here we have 4 label shows, and you can hide some of the values. So for example, now I do not want to have the second part of the first doublet shown, this 3/2. Then you create a one-word label. So if you just delete the space, that will create one word, and now it's is hidden from the label. You can do the same here. Now it's gone. And if you don't want the raw data, the background, you can go in the toggle menu and just flip between the different mode. So now, sorry, this is the wrong one, the Y label. You can go to the legend, and now you get a more compact legend. And even if you flip between different pages, this will stay. Obviously here, this is not done, so we can also do the same for the titanium. And go back, and you can see this is all there. If you want to put it back, it will look on, you can hide it completely. It will look like it's not working, but actually when you refresh the page, it's there. Okay. There are more icons. This is one that is a bit mysterious to you, but for example, if you have added an Excel page and further data into your Excel, and you've already done some fit, let's say in titanium, carbon, oxygen, all of those, you may, and so they are somewhere in there, you can't see it. Then, because it's not in the JSON yet, you may want to do a refresh, and the refresh will show you this new page. Just make sure you add the page, and if I go to the LSSTO, make sure I will just do an example, for example. So this is a titanium 2p try, join scan, and make sure you put it before the results table. So for example, if I add into the results table, so the results table is the results grid table. So if I simply add some, let me close that as well. Okay, so if I add some data into the results grid, and now I save the table by, I could save it by saving all sheet, or simply using the save results table. Now we would have a results table shown at the end. Yeah, right here. So this is the last one. Any pages that is added after is not going to be looking. The program will not be looking at them. So you can put some experimental description or something afterwards, it will not be looking. But let's say now I want to add also something like LA. So I will use the copy, move our copy, this one, and I'll call it LA 3D. Yeah, it's not LA 3D, but let's say I've added LA 3D. So I save that. It may say that I can't save the data because it's read-only. Okay, so I will don't save that. I have to close the program, unfortunately, I think, or simply open a new file. So let's go again. Move our copy, the Oxygen 1S, create a copy, LA3D. I'll put it just before the results table. I save it. I have to, sorry, I have to, this is a Windows issue. I have to really close the program. Maybe save now. Don't save. Let's do it again. Oxygen 1S. Create a copy. LA3D. So let's put it there and save. Now let me reopen the KherveFitting program and I'll put it. Okay, so this is now open. And if I open my LA strontium titanium 03, I will only get what I thought. Oh, okay, this time is added actually the LA3D. So actually, yeah, and it's not working. Okay, it's just not working. No available data because the JSON file is not been updated. Okay, so let's go back to strontium and let's do a refresh. So now it has refreshed all the pages. So what is done is it's refreshed the JSON file, and unfortunately we will get the results table, but then the Lanthanum 3D should be available, especially if we open it a second time. So if I go to hard carbon and I go back to lanthanum strontium, then I should be able to get the lanthanum 3D. So let me. Okay, actually, let me close the program. Let's try it again. Okay. That is it. I needed to click it twice. Okay, so it's a bit not working too well yet, but the next version I should be able to sort it out. But if you just try a few times, obviously we have the results grid, so this is not too good. I can save it, and now, and I think this is what I've made as a mistake, I didn't save it. If I now reopen it, we open it now, then simply we have the LS3D, which is actually an Oxygen 1S. Okay. That is it.